the moon will break apart. Not in some abstract, eventually, heat death of the universe sense. The moon has a specific ending, scheduled for a specific time by a specific mechanism. The mechanism has been observed happening to other moons around other stars. We can watch the future of the moon happen elsewhere, right now, through telescopes. This is when. This is how. This is what the sky will look like while it happens. There is a line around Earth. Inside the line, nothing the size of the moon can survive. The tidal forces stretching a body along the Earth-Moon axis exceed the gravitational forces holding the body together. The body comes apart. The line is called the Roche limit. Edward Roche calculated it in 1848. For the moon around Earth, the line sits at approximately 9,500 kilometers from Earth's center. The moon is at 388,000 kilometers. It is 40 times beyond the line. It is moving farther from the line every year. Saturn's rings exist because the ring material is inside Saturn's Roche limit. Anything that drifts in from outside gets torn apart and joins the rings. Anything inside cannot accrete into a moon, because the same forces that destroy moons prevent new ones from forming. Under the current dynamics, the moon will never reach Earth's Roche limit. It is moving the wrong direction, 3.8 centimeters per year outward, for 4.5 billion years and counting. The current dynamics are not the only dynamics. In approximately 5 billion years, the dynamics change, and the line starts moving toward the moon. The sun is halfway through its life. It has been burning hydrogen for 4.6 billion years. It has approximately 5 billion years left in this configuration. Then it changes. When the sun runs out of hydrogen in its core, it does not dim, it opens. The outer layers expand outward and the surface cools. The sun becomes a red giant. At maximum extent, the sun's surface reaches approximately where Earth is now, 150 million kilometers from the sun's center, one full astronomical unit. The sun expands to engulf its own inner planets. Mercury is absorbed first. Venus follows. Earth's fate depends on details. The sun loses mass during expansion, which weakens its gravity and lets Earth's orbit drift outward. But tidal interactions between the expanding sun and Earth drag Earth back in. The models disagree on which effect wins. The best current work suggests Earth is engulfed, but barely. The moon, in the same models, is in a worse position than Earth. The moon is smaller, lighter, and orbits Earth at a distance that puts it inside the sun's outer atmosphere, along with Earth itself. Whatever happens to Earth, the moon experiences it first, and more intensely. The moon's surface heats to temperatures that vaporize rock. The regolith does not melt and pool, it boils off into space. The moon begins to lose mass to the sun's atmosphere around it. This is not the breakup. This is the prelude. The moon is shrinking, but it is still in one piece. The breakup requires something else. The sun's outer atmosphere is thin, but it is not nothing. The Earth-Moon system, by this point, is orbiting through gas. Gas produces drag. Drag removes orbital energy. The moon's orbit around Earth begins to shrink. The recession that has been ongoing for 4.5 billion years reverses. The moon, which has spent its entire history spiraling outward, starts spiraling inward. At the peak of its recession, the moon will be approximately 163,000 kilometers from Earth. From that maximum, it begins to fall. The fall is slow. The drag forces are weak, but they are constant, and they have hundreds of millions of years to act. The moon descends through the distances it took 4.5 billion years to climb. 400,000 kilometers, 300,000, 200,000, 100,000. The moon is now closer to Earth than it has been since the first 100 million years after its formation. 50,000, 20,000. The moon is approaching the line that has been waiting for it for 5 billion years. The line is at approximately 9,500 kilometers from Earth's center. The moon, smaller now than it was when this began, has lost perhaps a quarter of its mass to vaporization. Its own Roche limit relative to Earth has shifted slightly. The exact crossing distance depends on what the Moon has become by this point, but it is in the range of 8,000 to 12,000 kilometers. The Moon crosses the line. What happens next is not slow. The forces that have been balanced for 4.5 billion years, gravity holding the Moon together against tidal stretching, trying to pull it apart, tip, stretching wins. The Moon begins to elongate along the Earth-Moon axis. The elongation is not a deformation the Moon's structure can resist. The Moon is a rocky body held together by its own gravity. Its tensile strength is negligible compared to the tidal stress now applied to it. The Moon stretches past its elastic limit and begins to break. The first break is along the long axis. The Moon splits into two large fragments, then three, then more. Each fragment is itself inside the Roche limit, and each fragment is stretched by tidal forces, and each fragment breaks further. The cascade is fast. Within hours, what was a single body becomes a cloud of fragments orbiting Earth in a line strung out along the original orbital path. The fragments closer to Earth move faster than the fragments farther out. The cloud stretches. Within years, the cloud is wrapped around Earth into a complete ring. Within decades, the ring has spread and flattened. Earth has rings now. Brief, glowing rings made of the disrupted Moon, illuminated by the red surface of the sun filling half the sky. This is the moment. This is what the Moon becomes. The rings are not stable. The same drag that brought the Moon to the line acts on the ring particles. The ring decays inward, the fragments falling to Earth, which by this point is itself either molten or vaporized. The fragments are absorbed into Earth, and Earth is absorbed into the Sun, and the system that began 9 billion years earlier ends in a single body of plasma indistinguishable from the rest of the Sun. We know this sequence works because we have already seen it. In 2015, Andrew Vanderberg and colleagues at Harvard identified an object designated WD 145 plus 017. It is a white dwarf, the burned-out core of a star that has finished its red giant phase. The white dwarf shows irregular dimming. Something is passing in front of it, blocking light at intervals that do not correspond to a single object. The pattern is consistent with a disintegrating planetary body at the white dwarf's Roche limit, spreading into a debris ring, fragments at slightly different orbital distances, passing in front of the star at slightly different times. WD 1145 plus 017 is showing us the breakup process directly. A body, the rough size of a moon or small asteroid, is being torn apart at the line, right now, and we can watch it happen by measuring how the star's light changes. WD 1155 plus 107 was the first. It is not the only one. By the mid-2020s, dozens of white dwarfs have been identified with similar debris signatures. The atmospheres of many more are contaminated with elements characteristic of rocky planetary material that has already finished falling in. Tidal disruption of moons and small planets at the Roche limit appears to be common during and after the red giant phase. It is the normal way that planetary systems end. When you look at those systems, you are looking at the Earth-Moon system 5 billion years from now. The breakup that will happen here is happening there. We can watch it through the telescope while it is being scheduled in our own sky. Could the Moon ever break apart? Yes. When the Sun expands into a red giant, the Moon will be heated until its surface boils into space, dragged inward by atmospheric drag through the Sun's outer envelope, and torn apart at the Roche limit. It will become a ring of debris around Earth. The ring will fall to Earth. Earth will fall to the Sun. The mechanism is observed, the timing is calculated. The Moon's ending is not a guess. Before the breakup, the Moon will spend approximately 5 billion years receding from Earth, reaching a maximum distance of 163,000 kilometers, then reversing and falling back. The reversal will take approximately 1 billion years. The breakup itself, once it begins, will take hours. But the Moon will not be witnessed when it ends. Complex life on Earth will end approximately 2 billion years from now, when the moon has receded far enough that its stabilization of Earth's climate fails. The biosphere will be gone for 3 billion years before the moon's breakup begins. The moon will be alone above a dead Earth for most of the time it has remaining. It will continue to recede across the silent surface of a planet that has nothing left to lose. It will reach its maximum distance with nothing watching. It will begin to fall with nothing watching. It will cross the line with nothing watching. The breakup, when it comes, will happen above a world that has been empty for a span of time 3 times longer than complex life has existed on Earth so far. The moon's ending is a private one, witnessed by nothing, in a system whose biological history ended billions of years earlier. This is what is scheduled. This is what is currently happening at WD 1155 plus 017 and the other dying systems. This is the long ending of the world that includes you, almost all of which happens after everything that could have remembered it is gone. The moon you see tonight has 5 billion years left. For 2 billion of them, there will be something on Earth to look up at it. For 3 billion of them, there will not. Then it will break apart, and the line that has been waiting will finally catch it, and the system will end the way other systems have already ended. That is how the moon breaks apart.